Welcome to Facts That Sound Fake But Aren't. The theoretically possible addition. Every event in this episode could happen. None of them violate the laws of physics. The universe permits all of them. The universe just hasn't gotten around to most of them yet. Let's get into it. You cannot shuffle a deck of cards to the same order twice. In practice, the number of possible arrangements of a standard 52 card deck is 52 factorial, written as 52 exclamation mark, which equals approximately 8 times 10 to the power of 67. That is an 8 followed by 67 zeros. To put that in perspective, the observable universe is roughly 13.8 billion years old, which is about 4.3 times 10 to the power of 17 seconds. If every person who has ever lived had been shuffling a deck of cards every second since the Big Bang, the total number of shuffles performed would still be nowhere near the number of possible arrangements. Every time a deck is properly randomized, it almost certainly produces an ordering that has never existed before in the history of the universe, and will never exist again. When you shuffle a deck of cards, you are in all probability creating something genuinely unique. You are also statistically incapable of doing it twice. A coin landing heads 100 times in a row is possible. The probability of a fair coin landing heads on any single flip is exactly 0.5. The probability of it landing heads twice in a row is 0.25. The probability of 100 consecutive heads is 0.5 raised to the power of 100, which is approximately 1 in 1.27 nonillion, a number with 30 zeros. This will almost certainly never happen in observable human history. But there is nothing physically preventing it. Each flip is independent. The coin has no memory. The universe places no prohibition on this sequence. If you sat down and flipped a coin for the rest of your life, the sequence heads 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 repeated indefinitely is exactly as likely on any given run as any other specific sequence of the same length. What feels impossible is just improbable. The distinction is everything. All the air molecules in a room could spontaneously move to one corner. A room contains roughly 10 to the power of 27 air molecules, all moving randomly at high speed in every direction. Statistically, these molecules are evenly distributed throughout the space. But there is a non-zero probability, permitted by thermodynamics, that at any given moment, every single molecule happens to be moving toward the same corner simultaneously, creating a perfect vacuum in the rest of the room. This probability is so small, it is essentially zero in any practical sense. If you waited for a time vastly longer than the current age of the universe, you would still be unlikely to see it. But the laws of physics do not forbid it. The second law of thermodynamics is a statistical law, not an absolute one. Entropy usually increases. It does not have to. Winning the lottery with the same numbers on 2 consecutive draws is permitted by probability if a lottery requires choosing 6 numbers from 1 to 49. The odds of winning a single draw are approximately 1 in 13.9 million. The odds of the same 6 numbers being drawn in 2 consecutive draws are that probability squared, roughly 1 in 193 trillion. Improbable at a scale that dwarfs human comprehension, but not impossible. Each draw is an independent random event. The lottery machine has no mechanism for remembering what came before. From a purely mathematical standpoint, the sequence in which the same numbers appear twice in a row is not a special case that the universe protects against. It is simply one possible outcome among trillions, weighted exactly as heavily as every other specific pair of consecutive draws. Every atom in your body could quantum tunnel through a solid wall. Quantum tunneling is the phenomenon by which a particle can pass through an energy barrier it classically should not be able to cross. It is not theoretical. It happens constantly at the subatomic level, and is the basis of nuclear fusion in stars. The probability of a single particle tunneling through a barrier drops exponentially with the size and mass of the particle. For a single electron, tunneling through a thin barrier is routine. For a proton, rare. For an atom, extraordinarily rare. For a human body, containing roughly 7 times 10 to the power of 27 atoms, all tunneling simultaneously through a solid wall is so improbable that the expected waiting time far exceeds the current age of the universe by an incomprehensible margin. But there is no law of physics that says it cannot happen. The probability is not zero. It is just a number so small it has no meaningful human equivalent. A monkey randomly typing at a keyboard will eventually produce Hamlet. This is called the infinite monkey theorem, and it is mathematically precise. Given a monkey pressing keys at random on a keyboard with 50 keys, the probability of producing any specific sequence of characters approaches 1 given infinite time. Hamlet contains roughly 130,000 characters. The probability of producing it on a single attempt is 1 in 50 to the power of 130,000, a number that would take more digits to write down than there are atoms in the observable universe. But the theorem does not require a specific attempt to succeed. It requires an infinite number of attempts. Given unlimited time and trials, any finite string of characters, including the complete works of Shakespeare, will appear. The constraint is not physical. It is temporal. The universe, as far as we know, will not last long enough to make this likely. But it will also not, as far as we know, last infinitely long. The monkey has not been given enough time. Not that it cannot succeed, just that it has not yet. A glass of warm water could spontaneously freeze on a hot day. The second law of thermodynamics states that entropy in a closed system tends to increase over time. Heat flows from hot to cold. A warm glass of water left in a warm room does not spontaneously freeze. Except that this is a statement of overwhelming statistical probability, not physical law. The molecules in that glass of water are moving at a range of speeds in random directions. In the overwhelming majority of states, the faster-moving molecules remain evenly distributed throughout the liquid. But there is a vanishingly small probability that through random motion, every molecule in the glass simultaneously happens to be moving slowly enough, and in the right configuration, to form a crystalline solid, ice. This has never been observed. It will almost certainly never be observed. But a universe that permitted it is the one we live in. Ludwig Boltzmann, who developed statistical mechanics in the 19th century, spent much of his career trying to explain why entropy increases, and found the answer was statistical, not mechanical. The warm water does not freeze because the odds are impossibly against it. Not because it is forbidden. Two people could generate the exact same cryptographic key by chance. Modern encryption relies on generating random numbers that are astronomically unlikely to be guessed or duplicated. A standard 256-bit encryption key has 2 to the power of 256 possible values, approximately 1.16 times 10 to the power of 77. This is larger than the estimated number of atoms in the observable universe. If every computer ever built had been generating random keys every nanosecond since the universe began, the probability that any two of them had ever produced the same key would still be negligible. Cryptographers design systems around this near impossibility and consider it functionally equivalent to actual impossibility. But there is no physical law preventing a collision. Two key generators could, by pure chance, produce the same 256-bit string. Every security system on Earth relies on this not happening. Every security system on Earth is, technically, relying on a very good bet rather than a certainty. The exact sequence of events leading to your birth could theoretically repeat your existence required a specific sperm cell, carrying a unique genetic combination, to fertilize a specific egg on a specific day, out of hundreds of millions of competing sperm cells. That event required your parents to have met, which required a specific sequence of decisions, encounters, and circumstances over their entire lives. That required their parents to have met, and so on. When evolutionary biologist Stephen Jay Gould proposed rewinding the tape of life and replaying it, he argued that the result would be unrecognizably different, that intelligence, or anything resembling it, was not inevitable. What is certainly true is that the specific chain of events producing you, with your specific genome, your specific neural architecture, your specific identity, required a sequence of events of essentially incalculable improbability. Not impossible, not prohibited, just the most unlikely thing you will ever try to explain. A Boltzmann brain could spontaneously assemble from quantum fluctuations in the far future. After stars have burned out and matter has decayed, the universe is expected to reach a state of maximum entropy, a cold, dark, nearly uniform expanse. But quantum mechanics permits random fluctuations in the vacuum of space. In a universe with infinite time, any configuration of matter that is physically possible will eventually be produced by random fluctuation, given long enough. This includes configurations that happen to constitute functional human brains, complete with false memories of a life never lived, spontaneously assembling out of nothing for a moment, before dissolving back into thermal noise. Physicist Ludwig Boltzmann considered this possibility in the 19th century. Cosmologists take it seriously enough to use it as a test for theories of the universe. A theory that predicts more Boltzmann brains than evolved observers is considered to have failed. The expected timescale for a single spontaneous brain assembly is so vast that the number cannot be meaningfully written down. But the physics does not forbid it. You could be one right now. You have no way to rule it out. Every raindrop in a storm could fall in a geometrically perfect grid. Rain falls because water droplets in clouds become heavy enough to overcome air resistance, and gravity pulls them toward the ground. The precise location where each drop lands is the result of the drop's trajectory, wind currents, turbulence, and the initial conditions of its formation in the cloud. All of these are governed by physical laws. None of them prohibit, at the level of physics, a configuration in which every drop in a storm happens to land at points on a perfect lattice, equally spaced in every direction, forming a mathematical grid across the landscape. The probability of this occurring naturally is so low that it has never happened and will never happen in any meaningful sense. But it is not magic. It is just a very specific outcome within the solution space of all possible rainstorm outcomes. The storm does not check whether the pattern it produces is orderly before proceeding. A protein could spontaneously assemble in the correct order from random components. Life depends on proteins, which are long chains of amino acids folded into specific three-dimensional shapes. A typical protein might contain several hundred amino acids, each chosen from 20 possible types, in a specific sequence. The probability of that sequence assembling correctly at random, each amino acid slot being filled by the right one independently, is 1 in 20 raised to the power of the protein's length. For a modest 300 amino acid protein, that is 1 in 20 to the power of 300. A number so large it makes the deck of cards comparison seem trivial. This is why abiogenesis, the origin of life from non-living chemistry, is considered one of science's great unsolved problems. Random assembly is not the proposed mechanism, but it is not prohibited. The universe in which a functional protein could snap together by pure statistical accident is this one. The probability is not zero. It has just never happened outside of carefully arranged chemical conditions. You could roll a die and get the same number 100 times in a row. A standard 6-sided die has a 1 in 6 chance of landing on any specific number. The probability of rolling the same number 100 consecutive times is 1 in 6 to the power of 100, approximately 1 in 1.53 times 10 to the power of 77. That is similar in scale to the number of atoms in the observable universe. If every atom in the universe were a die being rolled once per second, for the entire history of the universe, the expected number of runs of 100 consecutive identical results would be essentially zero. But the physics of each roll is independent. The die has no memory. Nothing prevents the molecules of the die from settling into the same orientation 100 times. It is simply a state space with many more other states than that one. And that is the theoretically possible episode. The general addition. Every event described here is real. None of them violates physics. The universe simply has not gotten around to them yet, and in most cases, will not, in any time frame meaningful to life. But the laws of nature are written in probability, not prohibition. The difference between impossible and merely unimaginably unlikely is one of the more unsettling things mathematics has to offer. More episodes coming.